To find the directional derivative of the function g of r comma s, which is given as the tan inverse of rs at the point 1 comma 2, we should first define the unit vector for this direction vector. That is, let me write this unit vector as u vector, and this equals v vector divided by its magnitude. So let's find this unit vector. We have to find the magnitude of the unit vector. So the magnitude of the vector, the magnitude of the v vector, and this equals, we have to take the square root of the sum of the components, square of the components, that is 5 squared plus 10 squared, and this equals 5 squared is 25, and the 10 square is 100, and this is under the square root, and this equals 25 plus 100 is 125. We can simplify this further. That is, I write down 125 as 25 times of 5, specifically as a product of perfect square. So this can be written as under the root of 25 times under the root of 5. So the square root of 25 is 5. So it basically reduces to 5 root 5. So this is the magnitude of the v vector. Therefore, we write u, and this equals v vector. I write the v vector in component form, that is 5 comma 10, and this is divided by the magnitude, which is 5 root 5. So we can split this and write this unit vector as incomplete vector form. So we write this as 5 divided by 5 root 5, comma 10 divided by 5 root 5. And this gets simplified to this 5 and 5 gets cancelled, and I can divide 10 by 5. It goes 2 times. So I write u equals, we have 1 over root 5, comma, this is 2 over root 5. So this is the unit vector that we have found. I'm going to consider this value as a and 2 over root 5 as b. Okay, so now let's find the partial derivative of the function g of r comma s with respect to r as well as with respect to s. So first I find the partial derivative of the function g with respect to r. So I write g sub r of r comma s, and this equals, we find the derivative of this tan inverse of x, and this equals 1 over 1 plus rs, this is quantity square, and we have to apply the chain rule to find the derivative or the partial derivative of rs. Since we are doing the partial derivative with respect to r, we treat s as constant, so therefore its partial derivative of rs is s, so we just multiply with s here. Now let's find the partial derivative of the g with respect to s. So I write down g sub s or s, and this equals, the derivative of tan inverse function is 1 over 1 plus the uh, the, the term in the tan inverse function, that is rs quantity squared. Once again, now we find the derivative of the rs. This time we find the partial derivative with respect to s. So we have to treat r as constant, and then derivative of s is 1, so we just get to r. So we multiply this quantity by r. So now we can write the formula for the directional derivative of the function g of r comma s. So directional derivative of g of r comma s, and this equals, I'm writing the formula, this is a times of the partial derivative g of r of the function plus b times of the partial derivative of g with respect to s. So let's substitute a and b as well as the partial derivatives. We know that the a is 1 over root 5, So plug in a equal to 1 over root 5. This becomes 1 over root 5 times g of r, which is s divided by 1 plus rs quantity square plus b is 2 over root 5. So I write 2 over root 5 times the partial derivative of g with respect to s, which is r over 1 plus rs quantity square. So basically, this is the expression for the derivative of the function g of r comma s. But since we want to find the directional derivative of the function at 1 comma 2, we plug in r equal to 1 and s equal to 2 into this directional derivative expression. So therefore, we get the directional derivative at the point 1 comma 2, and this equals 1 over root 5. Plug in s equal to 2, so therefore this becomes 2 divided by 1 plus we will find this rs quantity square. Rs quantity square, this equals r equal to 1 and s equal to 2, so this is quantity square. 1 times 2 is 2, so it is 2 square, which is 4. So basically rs quantity square is 4, so I plug in r, I write 1 4 here, plus 2 over root 5, the next term, times r is 1 divided by, once again we have this 1 plus r as quantity square, so it is 4. We can simplify this and evaluate. So we get 1 over root 5, this is 2 by 5 times plus 2 over root 5 times this is 1 over 5. Let's simplify and evaluate. So the product of 1 over root 5 times 2 over 5, this equals the denominators will get multiplied. 2 times 1 is 1 and 5 times root 5 is 5 root 5. And similarly, if we multiply the second term, we get 2 over 5 root 5. So these two are same similar quantities, which means if we put the common denominator 5 root 5, we get 2 plus 2, and this equals, we get 4 over 5 root 5. In fact, we can put this in rationalized form by rationalizing this value. So I multiply both numerator and denominator by the radical root 5. So we get 4 root 5 divided by 5 times of root 5 is 5. So this equals 4 root 5 divided by 5 times 5 is 25. So this is the directional derivative of the function at the point 1 comma 2 as well as in the direction of the v vector. And its decimal equivalent is approximately 0.3578.